Alright, for this case, I'm also going to talk about finding the critical points for these cases here. So the critical point for these cases here also the same. You will consider the, if you set critical point, you have to consider the dy dx to be 0, a stationary point, and dy dx undefined, right? A singular point. So now you should be better have better understanding about when they're asking you to find critical point. You must remember you have dy dx to be 0 or dy dx to be undefined. So of course you have to differentiate the function. So this one of course is using quotient rule, right? Quotient rule, you have v u prime. Differentiate, you have 2x minus with u differentiate this one, you have 2x, right? You have 2x. So divided by x power of 2 minus 9 to the power of 2, v squared. So if you're simplifying, then you are getting, okay, you can factor out the 2x. You can factor out the 2x, right? You can factor out the 2x. So after you factor out the 2x, you will have x to the power of 2 minus 9, right? X power of 2 minus 9 minus with x to the power of 2, right? X squared, 2x, you've taken out the 2x, so have x squared minus 9 minus x squared. So this one will eliminate. So you will be getting a remaining of, okay, so means your f prime x, you must differentiate correctly. So you are getting x power of 9, 2 minus 9 power of 2. Then of course x squared minus x squared, you will have 0, and you have negative 18x, right? 18x to be your gradient function or the derivative function. So okay, so later I want to show you how to using this gradient, this function, so the first derivative function, to find the critical points. Alright, okay, let's continue. Okay, this is a gradient function that I introduced just now. So there are two categories, critical points. You have dy dx 0 and dy dx undefined. But before that, the function given just now will be x power of 2 over x power of 2 minus 9, right? X power of 2 over x power of 2 minus 9. So for these cases, identify the domain first, because even though you find the value of x from these two cases, but the value of x that you get must in the domain for this function to be considered as a critical point. To be considered as a critical point, the value of x that you found here must be the elements of the elements inside the domain. So for these cases here, you can see that x cannot accept positive negative 3, right? You're putting 3 square, you're getting 0. You're putting negative 3 square, you're getting 0. So this is a singular point also, right? So this is a point where the denominator will become 0, right? So x cannot be positive. So it means that the domain for this f here is negative infinity up to negative 3, union negative 3 up to 3, and 3 up to infinity. Alright, means that from negative infinity up to infinity, we cannot accept. We open it means we cannot accept negative 3. Okay, we cannot accept negative 3. We cannot accept 3. Okay, if you find out that the value of x to be 3 or negative 3, then you cannot use that value here because you cannot substitute negative 3 here. You substitute negative 3 square, you are getting 0. A number cannot divide by 0, right? So means that undefined. So okay, now we consider the first cases, dy dx equals to 0. The f prime x, dy dx is f prime x. So the first critical point, consider f prime x equals to 0. So then we consider that negative 18x divided by x power of 2 minus 9 squared to be equal 0. Yes, this is possible to become 0 because there is an x here. So a over b equals to 0. If a equals to 0, means that negative 18x equals to 0. Then x equals to 0 is considered as a critical point. Why? Because 0 is in the domain, right? 0 is between here. You only cannot accept negative 3 and 3, right? So 0 can be accepted. But the 0 you can substitute into the function here to getting the value of y, right? So you substitute when x is 0, this is a critical point, right? This is a critical point. So when x equals 0, then y equals to 0 power of 2 or 0 square minus with 9. So you are getting 0, right? So it means that 0, 0 is a critical point. Is a critical point. And this critical point is a stationary point. Why? Why is it a stationary point? Because f prime x equals to 0. Because f prime x, the tangent is 0, right? The tangent is 0, either this way or this way. So now I'm going to find about another singular point. So where f prime x is undefined. F prime x is undefined. So f prime x is undefined. So you look at here. F prime x is only undefined when undefined. This is only undefined when the denominator is equal to 0. Right? F prime x is undefined when f prime x is undefined when x squared minus 9 to the power of 2 equals to 0. If you're solving this, 0, you're getting x squared minus 9 equals to 0. You're getting x to be plus minus 3. Can you accept this? Can you accept this? No, you cannot accept. Even though this will give these two values, they were giving f prime x to be undefined. But the problem is, this point you cannot put inside here, right? Because you put 3 square 9, okay. But if you put 3 here, 3 square minus 9, 3 square minus 9, you're getting 9 minus 0, right? Undefined. You cannot get the value of y here. You cannot form a coordinate. You cannot form a coordinate for these two values. So it means that there are no critical points. There are no points. Okay, there are no points. There are no critical points. Critical points that dy dx or f prime x to be undefined, right? No. So there are no. So it means that there are only one critical point here, which is a stationary point, 0, 0. So 0, 0 is the only critical points. Okay, so I'm going to sketching the graph for you also by using Desmos. Okay, this will be an easy way for you to understand. Okay, so you have to understand what is critical point first. So now you key in x squared over x squared minus 9. So you can key in x squared, right? X squared, then you key in divide. Okay, divide. Okay, you're pressing the button divide, then over. Then you have x squared minus 9. Okay, x squared, right? Square, x squared minus 9, right? Minus 9. Oh, sorry. So minus with 9. Okay, x squared minus 9. So, okay. So I zoom smaller. Can you see the graph? Can you see the graph? There are no dy, there are no critical point, no sharp point. So dy dx is undefined. If f prime x is undefined and there is a point, then that will be a sharp point. If you look at the graph here, there are no sharp point. If you go and scroll everywhere, you can scroll up to infinity. Okay, and you go and see there are no sharp point here. Okay, no sharp point. There are also no sharp point on the right and the left. But there is a stationary point here. So I zoom in. There is a stationary point here. Can you see that? This is a turning point. Go down. So it means that, can you see there is a horizontal tangent line? The x-axis is the tangent. So at this origin, the dy dx is 0. Okay. So for this graph, there is only one critical point. Alright. There is only one critical point, which is also a stationary point. Alright. Hope you understand.